Hi everybody! Welcome back for another amazing video! Yay! Woohoo! Today we're going to review and learn more about algebra. Algebra? What is algebra? That's a very great question. Algebra is the study of expressions, equations, and other algebraic structures. Wow! That's a big step! Yes. If you want to take algebra, you must know these concepts in order to master it. Dear family, in our math class, we are studying algebra. We will study algebraic expressions, how quantities vary together, and solving equations. These concepts are important for your child's success in middle school and high school math and science. An algebraic expression summarizes a calculation in a concise way. For example, we can write the calculation, subtract 3 from a number, and then multiply the result by 5, with the algebraic expression being s minus 3 times 5. The letter s is a variable that stands for a number. We can substitute any number for s and evaluate the expression to get a value. For example, if s is 4, then 4 minus 3 is 1, and 1 times 5 is 5. So the answer would be 5 if s is 4, because 4 minus 3 is 1, and 1 times 5 is 5. To help students interpret numerical and algebraic expressions, we relate them to math diagrams that indicate quantities. Wow! Like, see over here? 3 is the first number, so in the first box, there are 3 dots. But then there's also 2 times 5, which is 1 5 over there, and another 5 over there. 5 times 2 is 10. 10 plus 3 is 13. And that's correct, because 5 plus 5 is 10, and 10 plus those 3 equals 13. So yes, but we could also represent quantities with variables, like 3 plus 2 times d. D dots, like whatever number d is, we always know it's 2 of them, because it's 3 plus 2 times d, because it's 2 of the d dots group, but there's still 3 there, because it's 3. In this unit, we will study quantities that vary together. For example, the weight of potato salad and its cost vary together. The distance a person has walked and the time that has elapsed since the person started walking also vary together. To show how quantities vary together, we will use double number lines, tables, graphs, diagrams, and equations. Here is a double number line that shows distance and time varying together for a person walking at a constant rate of 3 feet per second. Okay, so if we look over here, the person is walking 3 feet in 1 second. This means that in 2 seconds, the person would have walked 6 feet, and in 3 seconds, the person would have walked 9 feet, and so on. It's a repeating pattern. In this unit, your child will also study how to solve equations. To solve an equation means to find the numbers that make the left side of the equation equal to the right side. Students find solutions of equations in several ways. They check numbers to see if they make the sides of the equation equal. For example, x equals 12 is a solution of 7x minus 1 equals 83, because 7 times 12 is 84, and 84 minus 1 equals 83. They reason about what number makes the two sides of an equation equal. For example, both sides of 14 plus 72 equals 72 plus x have an addend of 72. Therefore, the other addends must also be equal, so x equals 14. They use the inverse operation to write a related equation that is easier to solve. For the addition equation 32 plus x equals 51, we can write the related subtraction equation x equals 51 minus 32. Now it is easy to see that x equals 19. They apply the same operation to both sides of an equation to get an equivalent equation with the variable alone on one side. For example, multiplying both sides of 1/2 x equals 5 by 2 gives the equation x equals 10. If you have any questions or comments, please contact me. Sincerely, your child's teacher. Oh my gosh, that was a lot of information. I would be happy to repeat it, but it's a lot of information. Phew. Don't worry. Algebra may seem hard, but once you practice and practice, it may not actually look as hard as you think. A lot of new vocabulary words means a lot of new lessons of algebra are starting. Algebraic expression, associative property of addition, associative property of multiplication, base of a power, coefficient, commutative property of addition, commutative property of multiplication, dependent variable, distributive property, double number line, equivalent expressions, evaluate an algebraic expression, exponent, expression, factor tree, greatest common factor, independent variable, inequality, infinite, inverse operations, like terms, multiplicative inverse, numerical expression, order of operations, power, prime factorization, simplifying expression, solution of an equation, solution of an inequality, solution set, solve, term, and variable. That was a lot of words, too. Yes, and a lot of words is good because we want to expand our vocabulary. We are going to introduce variables, expressions, and terms. A variable is a letter or symbol used to represent a number. In Unit 2, you worked with variables and area formulas. For example, in the formula for the area of a triangle, a equals 1/2 bh, the numbers a, b, and h are variables. Remember finding the areas of triangles in Unit 2? We just had to do 1/2 times bh. So yeah, a, b, and h are variables. It's very simple. Write another formula that includes variables. Well, I know another formula, but just in case you don't know what the formula is, it is d equals rt. What is that equation? That is the distance formula, or the length of the distance. So, yeah, d equals rt is the distance formula. An expression is made up of one or more numbers, one or more variables, or both numbers and variables. An expression also often includes one or more operations, but does not include an equal sign. Be careful over here. 3 plus 5 equals 8 is not an expression because it has an equal sign. Some examples of expressions are shown below. Look at these. 4 is an expression because it is one number, and it's said that an expression must be made up of one or more numbers. Well, obviously, 4 is one number, so 4 is an expression. One or more variables also counts, which means that n is also an expression. X minus 9 is an expression. 3z is an expression. B plus 2 minus a is an expression. And half bh is an expression. But you have to be careful, because some expression-related structures are really not expressions, and they could try to trick you. Circle the expressions. Cross out the equations. Huh? Let's see over here. Well, an expression must include one or more operations, but not an equal sign. Let's see p divided by 7. P divided by 7. There's no equal sign, so yes, p divided by 7 is an expression. How about 13? Well, an expression is made up of one or more numbers, and 13 is a number, so I say 13 is an expression? That's right, because it stands alone as one constant. So, yes, 13 is an expression. P divided by 7 is an expression, and 13 is an expression. But how about z equals 6 minus x times y? Wait a minute. Did you say equals? That's not an expression. That's right, Frenchie. Because z equals 6 minus x times y obviously has an equal sign in it, so it cannot be an expression. An expression does not include an equal sign. But this one does, so it's not an expression. Good job! Now, an expression could also be made up of one or more variables. Well, obviously, t is one variable. So, t is an expression. But how about 7 plus 4 equals 11? That is true because 7 plus 4 does indeed equal 11. But is it an expression, though? Let's see. Well, 7 plus 4, yeah, it has numbers in it. Wait a second, there's an equal sign in that one, too. 7 plus 4 equals 11 is not an expression. That's right, Chekhov's V. This is not an expression because it has an equal sign. 7 plus 4 equals 11 is not an expression. But how about 0.5 times k plus s? You really have to be careful and keep an eye out for the equal signs, because if there is one equal sign, then it is not an expression. If there are no equal signs, then it is an expression. 0.5, yep, they got a number, times, they got an operation too, k plus s, which is two variables and another operation. Would you look at that? There is no equal sign. So I'll say yes, 0.5 times k plus s is an expression. That's right, Frenchie. 0.5 times k plus s is an expression because it does not have an equal sign. So, other examples of expressions include p divided by 7, 13, t, and 0.5 times k plus s. Well done! Write an expression that includes at least one number, at least one variable, and at least one operation. Can you make up your own expressions? Well, one variable I could name is x, right? X is a variable. One number I could name is 9. 9, very good. One operation that I could name is subtraction. Yeah, subtraction's an operation. If we combine those together, that makes x minus 9. So x minus 9 is an expression? That's right, because there is no equal sign. It only consists of one variable, one number, and one operation. No equal signs. So yes, x minus 9 is an expression. Very good! Terms are parts of an expression that are added or subtracted. Some examples of terms are shown below. For example, in the expression y plus 9, we see that both y and 9 are terms because they are being added together. G minus 2g has terms g and 2g. So in other words, the expression g minus 2g has two terms, g and 2g, because they are being subtracted together. And this expression has three terms, 3/4 a, b, and 1, because 3/4 a and b are added together, and b and 1 are being subtracted together. So it could either be added together, subtracted together, or a combination of both. Write an expression that consists of two terms that are numbers. Okay, it says here that terms are parts of an expression that are added or subtracted. So I'll do addition. Very good. And two terms that are numbers. 3 and 2 are two numbers. So is 3 plus 2 an expression? That's right. Be careful, guys. 3 plus 2 is an expression, but 3 plus 2 equals 5 is not an expression because 3 plus 2 equals 5 has an equal sign. So 3 plus 2 equals 5 is not an expression. But 3 plus 2 is an expression because it does not have an equal sign. So 3 plus 2 is an expression. Very good. An expression that consists of three terms, as we mentioned earlier, is 3/4 a plus b minus 1. Alright, sounds like we got the hang of expressions. Yeah, I think we'll do very good in algebra. But that's not all you have to learn. A numerical expression includes only numbers. So, for example, if we look back at 2 plus 3, 2 and 3 are numbers, and there is only addition. So, 2 and 3 are the only mathematical constants, and those two are both numbers. So 2 plus 3 is a numerical expression because it only includes numbers. So, if an expression includes one number but one variable, it's not numerical because a numerical expression must only have numbers. So 13 is a numerical expression because it only represents one numerical value. Follow the order of operations to simplify a numerical expression. The order of operations? Yes, the order of operations tell you what to do to simplify and evaluate numerical and algebraic expressions. The first step of the order of operations is to perform all operations inside parentheses. The second step is to multiply and divide from left to right. And the last step is to add and subtract from left to right. So, in order to simplify a numerical expression, we need 3 steps. Parentheses, multiply and divide, and add and subtract. So, in this case, 2 plus 9 is in parentheses, and parentheses is the first step. So we do 2 plus 9 first, which is 11. Then it says to multiply or divide from left to right. Well, multiplication is the only one of those two that appears here. So 9 plus 2 is 11, and 11 times 3 is 33. The last step is to either add or subtract from left to right. Well, obviously, subtraction is the remaining operation. So 36 minus 33 is 3. So the answer is 3. Wow, interesting. Can I try one? Yes, Byron. Remember, follow the order of operations. Let's see. There are no parentheses in this one, so we skip step 1? That's right, Byron. We go immediately to step 2 because there are no parentheses. Multiply and divide from left to right. Well, out of these, division is the only one. 8 divided by 2 is 4. That's right. And add and subtract from left to right. Out of these, only subtraction is present. So 20 minus 4 is 16. So the answer is 16. That's right, Byron. Wow, I could already feel you just zooming away. Yes. 20 minus 8 divided by 2 is 16, because 8 divided by 2 is 4. And 20 minus 4, you're right, is 1, 2, 3, 4, 16. You're right. So the answer is 16. I will do this one. 26 divided by 2 is 13. 13 times 3 is, hold on, let me do the math. 1, 2, 3, 1, 2, 3, 39. So, 26 divided by 2 is 13. 13 times 3 is 39. And 39 plus 11. Well, if you don't know 39 plus 11, do this fun little fact. I know that 39 plus 10 is 49. And 39 plus 11 is simply 39 plus 10 plus 1 more. So 39 plus 10 is 49, but then 49 plus 1 is 50. So the answer is 50. An algebraic expression is an expression that includes one or more variables. An algebraic expression summarizes a calculation in a concise way. For example, n plus 3 times 5 is a short way of saying add 3 to a number and then multiply the result by 5. To evaluate an algebraic expression means to substitute given values for the variables and then simplify by following the order of operations. So it's the same thing, except with slightly more steps. So if we wanted to evaluate x times 5 minus y for x equals 8 and y equals 3, then the x will be changed into the number 8 because x is 8. X is 8. So that means 8 times 5 minus y. Well, y equals 3, so the y will be changed into 3. So, the expression should look like this. 8 times 5 minus 3. Well, we write the given expression first, then substitute 8 for x and 3 for y, which we already did, perform the operation inside parentheses. 5 minus 3 is 2, and then multiply. 8 times 2 is 16. The expression simplifies to 16. So 16 is the simplified answer. Wow, very interesting. Yes, very cool. Evaluate each expression for a equals 3 and b equals 6. Okay, let me solve this one for you, because I think this one is quite tricky. So, when we look over here, a equals 3. So they already give you one obvious and subtle hint over there. One obvious hint, a is 3. So guess what? A is free. Wow, what a surprise. A is free. So 24 minus 15 divided by A is 24 minus 15 divided by 3. Because remember, A is free. So 15 divided by 3 is 5, because we have to divide first. Then we have to subtract. 24 minus 5 is 24 minus 4 minus 1 more. So 24 minus 4, I know, is 20, and 20 minus 1 is 19. So the answer is 19. Now, this one includes two variables, b and a, together. They are added together, so they are both terms. Remember, a equals 3. Subtle hint over there. But b equals 6. Another subtle hint, another obvious hint. So 10 times b plus a is simply 10 times 6 plus 3. Because remember, b is 6 and a is 3. So 6 plus 3 is 9. Because we have to perform the operations inside the parentheses first before we can multiply by 10. So 6 plus 3 is 9. And 10 times 9 is 90. So the answer is 90 for this one. How about this one? Let's see if you could try it. Let's see. A is 3, right? That's right. And B is 6. So first we have to perform multiplication, right? Yes, that's correct. You have to perform multiplication first. Before you could perform addition, multiplication is first. So A is 3. 2 times 3 is 6. And B is 6. So 4 times B is 4 times 6, which is 24. And A is 3, so 2 times A is 2 times 3, which is 6. Now we add 6 and 24 together. 1, 2, 3, 4, 5, 6. Is 30 the answer? You're right, Byron. Yay! I'm getting the hang of algebra now. Yes. 2 times A plus 4 times B is simply 2 times 3 plus 4 times 6, which is 6 plus 24, which is 30. So 30 is the answer. And this one I will help you with. 18 divided by A minus B divided by 2 equals 18 divided by 3 minus 6 divided by 2. Because remember, A is 3 and B is 6. Subtle hints. Now, this is a tricky one, but division is the first operation. So, A is 3. So 18 divided by 3 is 6. So this 18 divided by 3, or 18 divided by A, is 6, because A is 3. This is 6. Now, B divided by 2. B equals 6. So B divided by 2 is 6 divided by 2, because B is 6. 6 divided by 2 is 3. And 18 divided by 3 is 6. So 6 minus 3. 6 minus 3 is 3. So 3 is the answer. Wow! Algebra's amazing! Yes, it is. And we could also explore deeper algebraic concepts. But unfortunately, that was it from us today. But I hope you enjoyed expressions and equations, too. The study of algebraic structures is called, well, algebra. It has algebraic in it. It has algebra in it, so, yeah. But I hope you enjoyed this algebra video about how easy it is to identify the difference between expressions and equations. Equations have an equal sign. Expressions don't. Bye, everybody! Bye!